Alright, so now we're going to solve some linear inequalities. Alright, so I made this page a blank page because there's some things that I want to talk to you about and show you. Whenever you graph an inequality on the number line, remember this means, is less than, and whenever you graph a less than, then you will use an open circle. When you graph an is greater than, you will also graph an open circle where the number is that you want to graph. Whenever you graph an is less than or equal to, you will graph a filled in circle, a solid circle. Whenever you graph an is greater than or equal to, you will also fill in the circle. These are very important concepts for you to remember whenever you're graphing this, because they're definitely things that I look at whenever I grade your work. So you may want to take some notes on this and store this in your memory. Alright, so on part A, if I want to graph x is less than or equal to 1. Alright, so that means I want all of the numbers that are less than or equal to 1. So on my number line, I always draw at least 3 numbers. Always put at least 3 numbers on your number line. And I always put the number that I'm dealing with in the middle, and then I put a number on either side of it. Make sure you put the correct numbers on either side of it. I do grade that as well. Now remember, because it has the equal to symbol underneath, we're going to use a closed-in circle. And now I want all the numbers that are less than 1, so I'm looking for the numbers to the left. The line represents all of your possible answers. The arrow indicates that it keeps going on and on and on forever to the left. The arrow is very important too. The closed-in circle means that 1 could be a solution. Alright, so now let's look at part B. X is less than 5. So again, draw your number line. I put the number I'm dealing with in the middle, and I put 1 on each side of it. Because I don't have the equal to symbol, I want to put an open circle at 5. That means that 5 cannot be one of your solutions, but everything immediately, in this case we want smaller than, everything immediately to the left could be a solution. Now the reason why I didn't put a circle at 4 is because what about 4.999999? That's still less than 5. So that's why we put the open circle at 5. That means don't include this number in your solutions, but include everything immediately to the left of that. Alright, so on x is greater than -1. Be careful how you label these. Make sure that your numbers are in the proper order. And because we don't have the equal to symbol underneath, we want to put an open circle there at -1. And the greater than means you want all the numbers that are bigger than -1. Alright, so there are those 3 graphed on a number line. Alright, so now let's graph these on a number line. So I've got part A, which is x is greater than or equal to -3. Dealing with negative numbers, so remember those go in the reverse order. And I'm going to put a closed circle because I've got this equal to symbol underneath. Closed filled in circle right there at -3, and I want all the numbers that are greater than, and greater than is to the right. Don't forget your arrow at the end. And that's it for that one. Alright, part B, I've got x is less than 2.5. So I usually still deal with whole numbers here. So 1, 2, 3, that's not quite even, but it's close. And I would put an open circle at about 2.5, and again, since it's not labeled below, since we're not exactly at a whole number, I write the number above where I put that circle, and I want less than, so I want it to go to the left. All the numbers smaller than 2.5. And there you go. All right, let's look at part C. X is less than or equal to -3/5. So what I would do here is -3/5 is a little bit more than halfway to -1, between 0 and -1. So I'd put 0 here, -1, -2, and I want a closed circle at a little bit more than 1/2. And again, since it's not labeled at the bottom, I'm going to label it above. And then this points to the left because I want all the numbers that are smaller than -3/5. All right, that's it for that one. Okay, so this page is just telling you that all of the properties of equality that we have talked about so far still apply whenever you're dealing with inequalities. So the subtraction property of equality is the same as the subtraction property of inequality. What you subtract from one side, you also subtract from the other side. Same thing goes with the addition properties. Okay, so even on your homework, if it says write the solution in interval notation, I want you to ignore that part. We're not going to talk about interval notation in this class. So I do want you to do everything else though. N minus 1/2 is less than or equal to 5/8. And to solve this, you do the same thing that you would do if that were just an equal sign. You would add 1/2 to both sides. So I've got N is less than or equal to 5/8 plus 1/2, which is 9/8. Or you could say 1 1/8. So I could also write it like this. Either way, I think probably this one is a little bit easier to graph. So on my number line, I'm going to put 1 there, I'm going to put 0 there, and I'm going to put 2 there. 1 1/8 is approximately, I don't know, I'm guessing, about there-ish. Notice how I'm closing in the circle because we have the equal to sign underneath. It's less than, I want all the numbers that are less than, all the n's or variables or all possible numbers that are less than 1 1/8. All right, there we go. That's it for this one. Okay, so this page is letting you know that the division and the multiplication properties also still hold, but there is a major difference that does something whenever you multiply or divide by a negative number, and this is what I want you to look at right here. When we divide or multiply by an inequality by a positive number, the inequality stays the same. Okay, so that multiplying and dividing by positives doesn't do anything to it. But look what happens with negatives. The inequality reverses. That's a big deal. And the reason why that happens is, so I'll show you. So if we have 2 and we have 5, we know that 2 is less than 5. Everybody agrees that 2 is smaller than 5. But look what happens when you divide both sides by -1. I get -2 and -5. So now which one's smaller? The -5 is smaller than the -2. So that's why when you multiply or divide by a negative number, you have to reverse your sign. Okay, so for this problem, we've got 7y is less than 42. So if that were just an equal sign, what you would do to solve this inequality or equation would be to divide both sides by 7. You're still going to do that. We did not multiply or divide by a negative number, so our answer is y is less than 6. So I would draw a number line, and we don't want to write the solution in interval notation. Okay? So we do want to graph this on a number line though. I always put the number I'm dealing with in the middle, 2 numbers, one on either side, and then I want to put an open circle at 6, and I want the numbers that are less than that number, and those numbers are over here on the left. And that's it. Okay, so for this problem, check this out. We've got negative 10a is greater than or equal to 50. So now I'm going to divide both sides by negative 10. And I just divided by a negative number. Remember, whenever you divide or multiply by a negative, you've got to flip that sign around. So on the left-hand side, I'm just left with a. I've got to flip my sign around, and I'm left with a is less than or equal to negative 5. So again, I'm going to do the number that I'm dealing with in the middle and then one on either side. Because it has the equal to symbol underneath, I want to put a closed circle here. And where are your numbers less than negative 5? They're less than on the left-hand side. So that's it. Alright, so this page is just letting you know that x is greater than a is the same thing as a is less than x. But I will tell you this. Your variable being on the left is easier to graph on the number line, and it has to do with minnow blocks. But if you're comfortable with your variable being on the right, that's fine. But just remember, your variable being on the left is easier to graph for most people. Alright, so this problem here, we've got negative 20 is less than 4/5 u. So I want to divide both sides by 4/5, and I get negative 25, I believe. Did I divide by a negative number? This right here is the number you're worried about. If that number is negative, then you say yes and you flip your sign. But if that number is positive, then you don't flip your sign around. But look at this. Okay, so now I have my variable on the right-hand side. This right here is the same thing as, okay, so now and I would have a open circle at negative 25, and it points to the right. Alright, that's it for this problem. Alright, this problem, t is divided by negative 2 is greater than or equal to 8. In order to solve for t, we have to multiply both sides by negative 2. I just multiplied by a negative number, so I have to flip my sign around. And I want a closed circle at negative 16, and because I have less than, I want my arrow to go to the left. That's it. Alright, so for this problem, I've got 4m is less than or equal to 9m plus 17. So now I would subtract 9m from both sides. And again, that's just to get my variable terms away from my constant terms. So I've got negative 5m is less than or equal to 17. I don't flip my sign yet in that step because I didn't divide or multiply by a negative. But now I'm about to, so now I'm going to divide by negative 5. So I've got that m, got to flip my sign, is greater than or equal to negative 17/5, or you could write your answer as m is greater than or equal to negative 3 2/5. I think the 3 2/5 is a little bit easier to graph. So I've got, let's see here, I'm going to put negative 3 here, I'm going to put negative 2 here, negative 4, and negative 3 2/5 is almost a negative 3.5, but not quite. So it's about right here, and above that I'm going to write negative 3 2/5, and this thing points to the right because I want the numbers greater than negative 3 2/5. And now you're done. Okay, so now we're getting just a little bit more complicated here. And we have, let's see here, 8p plus 3 parentheses p minus 12 is greater than 7p minus 28. So now I'm going to distribute. So I've got 8p plus 3p minus 36 is greater than 7p minus 28. I'm going to combine my like terms. I've got 11p minus 36 is greater than 7p minus 28. So I'm going to move my p's to one side, my variable terms to one side, and my constant terms are going to be on the other side. I would add 36 to both sides. And now I would divide by 4. So I get that, and I don't flip my sign at all. I don't flip my sign because I never divided or multiplied by a negative number. Okay, so now to graph this, I want an open circle at 2, and it has to point to the right. There you go, you're done. Alright, so for this problem, I'm just rewriting it. So I have to distribute a couple of times. So I've got 8x minus 10 plus 2x is less than 4x plus 36 plus 6x. Now I'm going to combine my like terms on both sides. So I've got 10x minus, oops, didn't mean to write that, minus 10 is less than 10x plus 36. So now, if I do this, check out what happens. So actually I'm going to erase that 0. So that goes away and that goes away, and I've got negative 10 is less than 36. Is that a true statement? Yes. Negative 10 is less than 36. So your solutions would be all real numbers. And to graph that on a number line, it would be something like this. You don't even have to put a circle anywhere because your solution is all real numbers. And the yellow line represents every single number on the number line. So no matter what number you chose for x, it would work here. Okay, so for this problem, I strongly recommend that you grab your calculator. And I'm going to move my a's to one side, so on my calculator I'm typing in 1/3 minus 1/8. And I get 5/24. So I get 5/24 A is greater than 5/24 A plus 3/4. So if I subtract 5/24 A from both sides, I get that 0 is greater than 3/4. Is that true that 0 is greater than 3/4? Not true, so there are no solutions. So there's no graph that goes with this. Alright, so this is a page that you just might want to hit pause and write down some of these phrases that go along with these words. I'm sorry, with these symbols. Alright, so translate and solve. And we're not going to write an interval notation, graph on the number line. 12 times c, so I'm going to do 12c is no more. Now going back to this page right here, is no more is right here. So that means I want less than or equal to symbol. Less than or equal to, oops, that's a 96. So now divide both sides by 12, and I get that c is less than or equal to 8. And they want us to graph this on the number line. So I have an a closed circle at 8, and it's going to point to the left. That's it. Alright, last problem. 30, and we're not going to do that part. So 30 less than x, don't forget less than means we have to reverse the order, is at least. So I'm going to go back here, is at least, right there. So I want greater than or equal to 45. And to solve this, I would add 30 to both sides. So x is greater than or equal to 75. And I want a closed circle at 75, and it points to the right. Alright, so that's it for this lesson. If you have any questions, let me know.